Imagine an expanse so colossal, so immeasurable that it's measured in terms of time. This is the universe we live in, a mind-bogglingly immense entity, spanning approximately 93 billion light-years in diameter. To put this into perspective, a light-year is the distance light travels in 1 year. The fastest thing in the universe, moving at a speed of approximately 186,000 miles per second. It would take 93 billion of those light-years to encompass the breadth of the observable universe. Hence, when we gaze into the cosmic canvas of the night sky, we are not just witnessing space but also peering billions of years into the past. Truly, the vastness of the universe gives us a glimpse into its grandeur. However, the enormity of the universe is not our sole focus today. Our main subject of discussion is the universe's timeline, a topic dealing with scales and figures that are just as mind-boggling. Our universe's story began around 13.8 billion years ago, with a colossal explosion known as the Big Bang. This Big Bang wasn't a conventional explosion. It was a moment of creation, an event that marked the inception of time, space, and matter. Imagine all the matter and energy in the universe, everything we can see and even what we can't, compressed into an incomprehensibly tiny, hot, dense point. This is the singularity at the heart of the Big Bang theory. This singularity didn't exist in space because there was no space yet. It didn't exist in time either, as time hadn't begun. Then, in a moment less than a blink of an eye, this singularity began to expand, not like an explosion, but like a balloon inflating. And as it expanded, it cooled, giving birth to the laws of physics as we know them today. In the first few moments after the Big Bang, the universe was a hot, dense soup of particles. As the universe expanded, it also cooled down. This cooling allowed particles to combine and form protons and neutrons, the building blocks of atoms. These atoms eventually clumped together to form stars and galaxies, the cosmic structures we see today. But it wasn't an overnight process. It took nearly 400,000 years for the universe to cool enough for atoms to form and light to shine through. This light is still detectable today as the cosmic microwave background, a faint glow that fills the universe and serves as a snapshot of the universe at a very young age. So from a singularity smaller than the head of a pin to a universe that stretches billions of light years across, our universe has come a long way. It's a story of expansion and evolution, of particles becoming stars and galaxies, of darkness turning into light. In the wake of the Big Bang, the universe has been expanding and evolving, creating galaxies, stars, and planets. Our universe, as we mentioned before, is approximately 13.8 billion years old. You might be wondering how we've come to this staggering conclusion. Well, it's a result of tireless work by scientists who've utilized two key tools: cosmic microwave background radiation and the movement of galaxies. Firstly, cosmic microwave background radiation. Imagine it as the echo of the Big Bang, a kind of relic radiation that spread throughout the universe. By studying it, scientists have been able to estimate the age of the universe. Secondly, the movement of galaxies. It's a bit like rewinding a movie. If we observe how galaxies are moving apart now and then reverse that motion, we can estimate when they were all together in that singularity that sparked the Big Bang. And as the universe ages, it continues to expand and grow more complex. So what does the future hold for our universe? When will it end? Now that's a question that has intrigued scientists for years. Before we delve into some theories about the universe's future, don't forget to subscribe and hit the bell icon for more mind-blowing videos like this one. Alright, shall we proceed? First up, we have the Big Freeze. This theory suggests that as the universe continues to expand, it will eventually cool down. As galaxies drift further apart, star formation will slow and eventually cease. Over trillions of years, existing stars will burn, leaving behind a cold, dark universe. It's a chilling thought, isn't it? Next on the list is the Big Crunch. This is essentially the reverse of the Big Bang. If the gravitational pull of matter in the universe overcomes its rate of expansion, then the universe might begin to contract. This could result in a cosmic implosion, where everything is pulled back into a singularity. It's like the universe hitting the rewind button. After that, we have the Big Rip. This theory posits that the universe's expansion rate could accelerate indefinitely due to an excess of dark energy. This would eventually cause galaxies, stars, and even atoms to be torn apart. It's a rather violent end, wouldn't you say? Now, which of these scenarios becomes reality is uncertain. It hinges on factors like the universe's rate of expansion and the amount of dark energy present. There's a lot we still don't know about these elements. For instance, we're still trying to understand why the universe's expansion is accelerating and what dark energy is. But here's something to keep in mind as we ponder these cosmic questions. Despite the various theories, scientists agree on one thing: the end of the universe won't be for many billions of years. That's right, our cosmos still has a long way to go. So, keep looking up at the stars and remember, every night you're witnessing a small part of the universe's grand story. While we can't predict exactly when or how the universe will end, scientists are in agreement that it won't be for many billions of years. Before we wrap up, let's explore some truly astonishing facts about the universe. Firstly, let's dive into the universe's rate of expansion. It's increasing, and at an incredible pace. The universe is not only expanding, but accelerating, stretching out in all directions faster and faster. This mind-boggling concept, known as dark energy, is one of the many mysteries that continue to perplex the world's greatest minds. Next, try to wrap your mind around this. There are estimated to be about 2 trillion galaxies in the observable universe. Each of these galaxies contains millions, billions, or even trillions of stars, each one a solar system with its own planets. Those numbers are staggering to think about, aren't they? Now let's touch on the concept of multiverses. While this idea might sound like it belongs in a science fiction novel, it's a genuine scientific hypothesis. Some theories suggest that our universe could be just one of an infinite number of universes, all existing simultaneously. Imagine that. An infinite number of universes, each with their own laws of physics, their own galaxies, stars, and planets. Lastly, let's consider the sheer age of the universe. It's currently estimated to be around 13.8 billion years old. That's older than any of us can truly comprehend. To put it into perspective, if the universe's age were condensed into a single year, humans would have appeared on the last day, at the last minute, and the last second. These facts, each more astounding than the last, remind us of our place in the grand scheme of things. We're but a tiny, fleeting moment in the vast expanse of cosmic time and space. So let's keep exploring, keep questioning, and keep seeking the answers to the universe's most profound mysteries. And remember, the universe is so vast and complex that there's always more to discover. Here's one final mind-blowing fact to leave you with. We've journeyed through the enormity, birth, and future of the universe and marveled at some of its astonishing facts. But what if I told you that all we've discussed, all we've seen, all we've known about our universe is just a fraction of its entirety? What if there is much more to the universe than what we can currently observe? Intriguing, isn't it? So let's delve into the concept of the observable universe. The observable universe is the part of the universe that we can see or detect from our vantage point here on Earth, using our most advanced telescopes and detectors. It spans a diameter of about 93 billion light years. That's a number so colossal, it's almost impossible for us to comprehend. But here's the kicker. The universe is not static, it's not sitting still, it's expanding. And it's expanding at a rate faster than the speed of light. This means that there are parts of the universe that are moving away from us faster than their light can reach us. So, despite our best efforts and the most sophisticated technology, there are regions of the universe that are simply beyond our observational reach. This leads us to an intriguing conclusion. The observable universe, as vast and mind-boggling as it is, might just be a tiny fraction of the entire universe. Think about that for a moment. The universe could be many times larger, perhaps even infinite, compared to the part we can observe. The universe, it seems, is like an iceberg. We're only seeing the tip of it. Beneath the surface, there's a vast expanse waiting to be discovered, full of mysteries, full of wonders. That's right. Even though the observable universe is already incredibly vast, there's probably even more universe out there that we haven't discovered yet. Now that's a thought